In today's distributorless electronically controlled engines, combustion is heavily dependent on various smart sensors that feed data to multiple onboard computers. Sensors have become so important to vehicle operation that most late model vehicles have an average of 60 to 100 of them, and that number is only projected to increase in the future. And that brings us to the topic of this video, camshaft and crankshaft sensors. Modern engines need to know the position of the crankshaft and camshafts because the timing of the valves, fuel injectors, and ignition coils are continually optimized for the most efficient combustion event depending on the load and speed of the engine. Engines also need to know the position of the crankshaft for misfire detection. Let's take a closer look at the important role of these sensors, starting with camshaft sensors. Your customers might know these as camshaft position sensors or cam sensors. In a four-stroke engine, the crankshaft rotates at twice the speed of the camshaft, with each cylinder firing on alternate strokes. Typically located in the engine cylinder head, camshaft sensors determine which cylinder is firing in order to establish injector synchronization and coil firing sequence in distributorless systems. With automakers under continuing pressure to improve the average fuel economy of their fleets, modern engines are using variable valve timing systems with multiple camshafts. A typical dual overhead cam engine will have 2 to 4 cam sensors as well as a crankshaft sensor. So what can go wrong with camshaft sensors? The most common cause of failure are extreme temperatures, contamination, and general wear and tear. Now let's talk about crankshaft sensors. These are also known as crankshaft position sensors or simply as crank sensors. Crankshaft sensors set ignition time, supply the RPM signal, and determine engine speed. With most engines, the crankshaft position sensor also is the key component in determining a misfire. Common causes of failure for a crankshaft sensor include excessive heat, faulty wiring harnesses, and sensor movement. To minimize the chance of premature failure, you'll want to recommend camshaft and crankshaft sensors that are made with premium components and that undergo rigorous quality control testing. For example, crank sensors from Standard feature matching connectors and tin-plated brass terminals to ensure a watertight connection to the harness, while a protective sleeve prevents wires from chafing and creating short circuits. Standard crankshaft sensors undergo chamber testing that cycles from -40 degrees to 257 degrees Fahrenheit, as well as extensive end-of-line timing, pulse width, and signal amplitude testing. Camshaft sensors from Standard feature advanced circuitry that provides immunity from electromagnetic interference and sealed construction that withstands extreme underhood conditions. They're subjected to 48 to 64-hour vibration testing across 3 different planes to ensure performance under the harshest conditions, as well as a slew of other tests. In modern engines, pinpoint timing is critical, and camshaft and crankshaft sensors play vital roles in making sure everything is running like clockwork. If one of these sensors fail, there's a good chance that the other sensors are nearing the end of their service life too. So it's highly recommended to replace the cam and crank sensors together. I'm Josh Cable. Thanks for watching.